Good morning, sir.
Good morning, Shreya. People will join slowly, and we'll have to start. So we have to do third order characteristics now. So write down the characteristics. Characteristics. Point number one. First is the rate constant is equal to x by 2t. That already we have seen it. 2a minus x divided by a square a minus x whole square. This is the one. Second, uh, plot of 1 by a minus x whole square versus time is straight line. It will be straight line whose whose slope is 2k and intercept is 1 by a square. You can see from here also. Slope will be 1 by a square. Third point, rate increases. Rate increases. No. Rate increases by 10 cube times n cube times if concentration is increased by, if concentration is increased by n times. If you increase the concentration by n times, so it also increases by n cube times. Next point, unit of rate constant. Unit of rate constant is mole per square liter square then per time. Next point is your, they need infinite time for completion. They also need infinite time for completion. Next point is your time required for time required for completion of a definite fraction for a definite fraction of third order is directly proportional to directly proportional to the 1 by a square. Means t 1 by a is fraction proportional to 1 by a square. Okay, and for half-life, for half-life, for half-life, let's see, t 1 by 2. Okay, so that equal to how much value? So for t1 by 2, so we have take x equal to a by 2 and we can substitute the equation. So we know actually t is equal to a x by 2k and whole is your 2a minus x and then divide by a square into a minus x. So we can substitute. Okay, right. Just put the x a by 2. Okay, done.
Yes, sir.
You can write also here. I just understand. Okay, you can write here also. So tx by 2k and instead of t, we can substitute t1 by 2. This will be x will be equal to a by 2. So a by 2 into 2k. So it will be a by 2, 2k. This will be 2 into a. This will be a by 2. And this will be a square given here, a minus a by 2. So if you solve it, on solving, you get here 3 divided by 2k into k square. So are you getting 3? We are getting 3. Pakka we are getting 3. Yes. So therefore, t1 by 2 is proportional to 1 by a square. Hmm? It is proved. Actually, main thing is that if you remember the how to derive the equation, then this thing will be possible. Otherwise, so many formulas are there. Each and every formula you have to remember. So it is very difficult. It is better you try to know how to derivation take place because derivation will only help you. Yeah, derivation is very, very important. Otherwise, remembering formula is very difficult. Then examples of third order reactions. Okay, so write down examples. What happened?
Could you please read, sir?
Uh, so scroll up.
Yes, sir, I am copying it.
Okay, great.
Sir,
Uh-huh.
sir, isn't 1 by a square a constant, sir?
1 by k square.
1 by a square, sir.
1 by a square.
Yes, sir, isn't it a constant, sir?
Why it is constant? It is
Uh,
proportional now because so we got here value. Uh, 3 by 2k is constant, so t half is proportional to 1 by a square.
and sir, here I am getting 3 by 2k into a, sir, not a square.
3 by 2 into a. 3 by 2 into a.
3 by 2k in 3 by 2k a, sir.
How is possible? 2a minus a. No? How are you getting? Uh, I'm also getting same thing. Yeah. That's correct only. This will cancel out. 4 minus a will be a.
3a by 2 by a square, you will get 3 by 2, 3 by
Acha, okay, okay.
4k, sir.
1 by a. But actually given here the a square only. Okay, 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 okay. This is a
This
square.
square.
This is a square. Yeah, yeah, a square. Yes, yes. Hmm, hmm, correct, correct. So that's missing. Okay, done.
So, 1 minute, sir.
Okay. Nitric oxide plus oxygen will give you 2NO2. We can take X will be Cl and Br. This is also specific. And third equation will be 2 nitric oxide. A2 will give you oxides and A2. Yet again, A is equal to hydrogen or deuterium. 2Fe CO3 plus SnCO2 will give you 2Fe CO2 plus SnCO4. Then 2HgCl2. So these are the specific examples. Only these are for the JEE mains exam and the JEE advanced. They won't ask you these type of questions. Actually, rather if you see JEE advanced is easier than JEE mains. JEE mains you have to memorize so many things. But for JEE advanced, they no need memorization. Only you have to learn the concept. If you have done the practice too much, that's enough. I think this time when JEE mains is conducting examination, it is F5 now. Somebody was telling it's conducting 5 only. At the end of Feb, JEE mains exam is there. So half-life for the zero order reaction, how much? Remember, 1 by 2k something was there now. Half-life for zero order reaction was uh, initial concentration A by 2k, right? A by 2k. But for first order reaction, 0.6393 by k only. But and for second order, 1 by a, and third order is 1 by a square. And nth order is your nth order will be half-life will be equal to how much they have given? T to the power a 1 by 1 minus n. We can conclude also. Okay, have you written? Now, nth order reaction. So actually, they will not ask you problem. They will ask you the okay, which of the following statement is correct. Problem, all this they won't ask you. I hope. So let's scroll down. Have you copied all, everyone? For above reaction, the rate is equal to k, and we can use a to the power n value. That is the nth order. Okay, we have to take a, let's consider a hypothetical equation uh, follows nth order reaction. Na is giving you product. Okay, so at t equal to 0, this will be a and this will be 0. Okay, and at time t, at t equal to t, this will be x. Okay, this will be a minus x, right? This is x rate. So what is the rate? So we can say rate of reaction will be equal to, if you take in terms of product, dx by dt. Okay, let's take in terms of product. So this is equal to k into a minus x to the power n. Hmm? Again, we can write, so dx by a minus x to the power n is equal to k into dt, right? And then now, so we can write here on integration, on integration. So we can write here 1 by n minus 1. This becomes your a minus x n minus 1. And that is equal to kt plus c. Yes, we can write this quick equation. And when t is equal to 0, definitely x is also equal to 0. So, and thus c is equal to 1 by n minus 1 a to the power n minus 1. You can see very clearly. Putting this value in the above equation, putting this value in above equation, done this one. Yes. Hmm. So we'll get here, from here, writing this side. So 1 by n minus 1, and then again a minus x whole to the power n. That is equal to k into t plus c. C will be 1 by n minus 1 and a to the power n minus 1. Okay. So again, so k into t will be equal to this. We can transpose 1 by n minus 1, and we can write 1 by a minus x to the power n and minus x to the power, this your, this n minus 1 now, this will be n minus 1. So 1 to the power n minus 1 n minus 1. This will be n minus 1 minus a to the power n minus 1, bracket close. Then after that, so we'll get the final equation. I think this is the final equation. So k is equal to 1 by t and multiplied by 1 by n minus 1, and this will be 1 minus a by x n minus 1 minus a to the power n minus 1. So this is our final. Okay, okay, I will do scroll up. Okay, should I more?
So 1 minute, sir.
Just we are deriving. I think it's derivation not much difficult. Let's scroll up only.
No, sir. This is fine.
I think completed.
Yes, sir.
Hmm. So you can find the d half life also. What is the half life here? So if t equal to no, so for half life t 1 by 2. So we can take x equal to a by 2. Okay. So we can get here k t becomes your 1 by 2 into n minus 1. Yes. And this will be 1 divided by a minus a by 2 whole n minus 1. And this is your a to the power n minus 1. So 1 by t 1 by 2 into 1 by n minus 1. This whole becomes your a by 2 only. So this divided by a by 2 to the power n minus 1. This will be a to the power n minus 1. Right. So how much it will become value? So we can finally write 1 by t up. T 1 by 2, and obviously this will be n minus 1, and this will go up na, 2 to the power n minus 1, isn't it? 2 to the power n minus 1. Yes, this I think we have to take the value. 1 by a minus 1 will be outside. Better we take the factor also. 1 by a to the power n minus 1 is outside. Common, and here will be 2 to the power n minus 1, isn't it? And this will be minus 1, correct? Yes. Got it now? So we can write here t 1 by 2 is equal to 1 by k n minus 1. Okay, not n minus 1. The whole will be again 1 by, this will be also 1 by a to the power n minus 1, and this is n minus 1 minus 1. Or simplify, we can say t 1 by 2 is proportional to a to the power 1 n minus 1. N minus 1 or what? N minus 1 only. They are given wrong value. It is coming n minus 1 value after. Okay. So we can conclude from here also. N is the nth order only, isn't it? So we can find the first order, right? From here also for 0 order, isn't it? For 0 order, we can say very clearly t 1 by 2 is inversely proportional to a to the power 0 minus 1. So it will be t 1 by 2 is proportional to a. It's clear. I think we're getting a also, isn't it? We can conclude now. For first order, so t 1 by 2 is inversely proportional to a to the power 1 minus 1. So we can conclude t 1 by 2 is inversely proportional to what? A to the power 0 means independent of concentration. Yes, independent of initial concentration, isn't it? Similarly, for the second order, it is matching, isn't it? So t half is proportional to a 2 minus 1. So we can say t half life is a, isn't it? Similarly, for the third order, already we have derived all this equation. So we can say it's matching, full matching. T 1 by 2 is proportional to a to the power 3 minus 1. So therefore, t half life is proportional to a square. So like that we can derive it. So with this our all nth order reaction completed. So we'll go for the experimental determination how we can for the order of the reaction. There are so many ways to find the order of reaction. Experimental determination of order of reaction. So first is your integration method. So we have now discussed the characteristics. Wait. One we have missed. Characteristic missed. Okay. Characteristics of nth order. Okay. So we have to take the same thing. So three characteristics you can take it. One is your rate of reaction, rate of reaction becomes n to the power n times, okay, if concentration is increased by, if concentration is increased by n times. This is one point. Second point is the time required for the completion, time required for completion of a definite reaction, required for the definite reaction, a definite fraction, not reaction, definite time required for the completion of a definite fraction of nth order, okay, reaction is proportional to a to the power, how much given, n minus 1. Yes, 8 power 1 minus n, isn't it? It will be 1 by a to the power n minus 1, okay, or we can write here a to the power 1 minus n. We can also write now time is proportional to a to the power 1 minus n, or we can write here a to the power n minus 1. So in the examination, they can give both the equation, okay? Sometimes students get confused also. Here you have to take here n minus 1. You can use anything, this one or this one, right? Hmm? Either this one or this one. Both are same, only the it is reversed. And the third is unit of rate constant is unit of rate constant, that is mole 1 minus n, then liter n minus 1, then time 1. Yes, I think now you can remember, isn't it? Now we'll use the experimental determination of order of a reaction. So we'll do what are the different methods are there. So first we'll do the method of integration. Hmm. So first one is your method of integration. Method of integration. That is called E10 trial method. Hmm. So here we have to assume it is the simplest method to find the x, a, x, and t values, right, of the different orders. We are also right. It is simplest method, okay, in which the quantities. Okay, okay. It is the simplest method in which the quantities. It is the simplest method in which the quantities a, x, and t are determined. T are determined. Okay, and substituted in the and substituted in the kinetic equation of substituted in the uh, kinetic equation of the various order. Kinetic equation of various orders. So we'll just consolidate of different orders, right? So already we know the equation. So for zero order, or we can say for zero order, what is the equation? So k is equal to, if you remember, k is proportional to x by t, right? Isn't it? K is proportional to x by t for zero order. For the first order, okay, so we can write here k is equal to, so it is equal to x by t, it's not proportional. It will be equal to x by t. For the first order, k will be equal to 2.303 divided by t into log of a by a minus x, right? Remember, for the second order, okay, k will be equal to 1 by t, and this becomes your a, and x divided by a minus x. This is your second order. Similarly, for the third order, for third order, k will be equal to 1 by 2t, and then x by a, and this is equal to 2a minus x divided by a minus x whole square. Yes, isn't it? Or even we can write this also, or we can write 1 by t equal to 1 minus a minus x divided by 1 by a. We can also write like this also. And here also we can write 1 by 2t is equal to 1 by a minus x whole square divide minus 1 by a square. Yes, all we are already derived, isn't it? So 1 by a minus x. All these are repetitions. So I think you won't find any problem in understanding. So rate constant in every case will be different. Second, you can use the graphical method, isn't it? Second, we can use the graphical method. Graphical method to find the order of the reaction. So the graphical method, respective rate laws are used. Okay, you can use the rate laws. Okay, rate versus concentration. There are one, two, three, four. Four graphs are there. My God, here we have four graphs. Okay, here we have four graphs are there. Oh my God, how many graphs are there? One graph is plot plot rate versus concentration raised to the power n. This is one graph. Second graph is plot uh, t half versus concentration. Okay, and the third graph is plot plot dx by dt versus log of a minus x. This is the third graph, and the last graph is plot concentration versus time. Concentration versus time. So they are the four graphs there. Copy? Yes, done.
Yes, sir.
So four graphs are there. Rate versus concentration rate to the power time. Then T half life versus A, and concentration rate versus log of A minus X, and plot concentration versus time. So let us see one by one. How many graphs are there? If you draw this one graph, let's see one by one. Plot rate versus concentration. First is your plot rate versus concentration raised to the power n. Okay, so here it will be rate will be equal to dx by dt, that is equal to k into a minus x versus 10. Okay, so we can compare with y equal to mx plus c. So this is the y, and this will be mx plus c. We can compare with this one. Hmm. So by comparing, okay, we can plot that. So you will get, this is your dx by dt. This is a minus x. This is zero order. Okay, parallel line. We can plot the graph dx by dt. This will be a minus x. Okay, this graph will be straight line. This is the first order. Then we can draw dx by dt a minus x. Okay, it is square. So here graph will be again a straight line, second order. Similarly, if you draw the graph for the third order, so this is dx by dt a minus x whole cube. So graph will be again this one. Only there is difference of slope only. Slope is only variable, right? I think everywhere slope is k only, right? Slope is variable only. This is slope is variable. Now we'll draw second plot T half life versus A concentrations. This we have to plot. Yeah. So here T half life is your, we can put 1 minus n, or we can use a to the power n minus 1. Anything you can use it. Hmm? So in this way, first you copy them because we have to draw the graph of all. Have you copied this one? Yes. Rate versus concentration. So next we have first with zero order. T half versus concentration. Graph will be this for the zero order. A straight line. Okay. Then for the first order, graph will be parallel. This is T1 by 2, and this is the concentration. That is A only. This all are A concentration. Then graph will be for this is your second order. Your graph will be T1 by 2, 1 by A. Okay, they can ask you compare the graph of this and this also, which have what slope. Okay, that the kind of question can be asked in the examination. So it is a little tough question. It's not easy. You have to, if you remember, you can give answer. If you won't remember, this is very difficult to give answer. This is T1 by 2. This is your order. They can ask you to compare the slope of this and this both. So you have to give answer. Okay, all graphs are not same. Their slopes are different. Yes. And for nth order, T1 by 2 for nth order. The graph will be goes down only. A to power 1 by n. Okay. Okay, done this one. One we have done rate versus, this is the rate only. This is the rate versus A, both are A. This is A square and A cube. This is the half life. Now third graph, plot log of log dx by dt versus log a minus x. Dx by dt versus log a minus x consideration. Okay, so here we can write, so dx by dt is equal to k into a minus x to the power n. Hmm? So we can split dx by dt is equal to, this will be, oh, this will be log only, yes. Correct, this is log dx by dt. So dx by, if you multiply, applying the log, here we can write applying the log on both sides, applying log on both sides. So log dx by dt is equal to, this would be log a plus n into log a minus n. Yes, so we can see clearly, this is your y equal to mx plus c. So this is your y, this is log k is your intercept. So c plus m into x. So we can compare. This is, and we can plot the graph, isn't it? So if you plot the graph for this case, this is your log dx by dt. This will be log a minus x, and we'll get the value. This is the slope, isn't it? So this is the intercept. So this intercept is your log k, which is the intercept, isn't it? I think you have understood now. No problem. Yes,
Yes, sir. Yes, sir.
easy is easy. Only you have to remember formula. If you remember the formula, nothing is difficult. Okay. So we left last graph. Last graph is pending. Plot concentration A minus x versus time. This we left. Concentration A minus x versus time. Okay, so again we can plot the different graph that we know for zero order. For zero order, we know a minus x is equal to kt plus a. Kt plus a. This is already we know. That is, if you compare with the equation of straight line. So this is the conception y, and this is the mx plus c. We can compare it. Now we can plot the graph, isn't it? So here graph will be in concentration, or we can say rate versus k to the power sign. Here mx, sorry, mx plus c. This will be mx plus c. So we can compare, and here we can plot the graph. This will be a minus x, and this will be your time. So graph will goes down. This will be the slope. Slope will be down now. Mx plus c. But why it is going down? Minus kt plus c. Minus kt plus c. So it will go down only. Minus kt. Remember, it goes down only. Hmm? This is concentration. This is the time. And for the first order, or first order, graph will be now here in first order. What was the graph? So 1 by, that's also a straight line. All will be straight line. Here every graph will be straight line. So first order graph will be your y bands x2, that is t now, t equal to 2.303 by k, isn't it? And that is equal to concentration. We have to take concentration versus time now. It will be minus k by 2.303, isn't it? What was the equation? Remember, we have to take uh, k is equal to 2.303 versus time, and this is a log equal to a by a minus x, right? We have to take this concentration only, isn't it? So kt equal to kt by 2.303, isn't it? It is equal to log of a divided by a minus x. So you have to take a reverse way. How we take reverse way? We get in terms of log value now. Log a minus x we have to take it. So log a minus x will be this. We have to consider uh, if you take reverse minus 1. So kt divided by 2.303 equal to minus 1 log a minus x by a. Right. Okay, so if minus will come this side. Minus 1. Correct now? Actually, you have to substitute log A minus X by A is equal to, this should be like this one, 2.303 by KT. Sign will be minus. Oh no, exactly. KT now. KT divided by 2.306. That's clear now? Now we can plot the graph. So here if you plot the graph, so this will be your log A minus X, and this is your K will be minus sign now. So Y equal to minus mx plus c. So c will be a. So you will get the graph down, isn't it? So this is the log a. This is your time t, and this theta is equal to minus k by 2.03, isn't it? Hmm? Yes, okay, clear. See this, yeah, they will ask you the graph only, okay? So you have to remember. So this is a little confusion. If you have understood, if you have, so you can get the full marks. If you have not understood, you are going to lose marks. They are not going to ask much question. They will ask you the graph. Okay, so this is the graph they are normally asking. So students learn by heart. The graph is not difficult. They will learn by heart. They will score. But if you have made any mistakes from here, okay, so you will lose marks. It is very scoring subject is there, right? If you understood, so you won't lose marks 100%. But if you not understood, you will lose the marks. So they will ask you lots of graph from you. Which graph is first order, second order, this versus this versus this. So I am giving all, I'm solving every graph properly so that you won't make any mistake. Hmm? Uh, for second order, okay, so graph will be 1 by a minus x, and this will be time t. So you get the graph from here, right? Hmm? And this is your 1 by a is the intercept. Hmm? Slope will be k only. That is slope that is equal to k. Yes, I think we can derive the equation from here. Second equation, second derivation only. Yes. So if you remember, kt is equal to x by a into 1 by a minus x. Is it okay? So we can multiply 1 by a minus x, and that is equal to kt into a, right? 1 by a kt into a and divide by x, isn't it? So we can take, this is the y now, y equal to will be mx plus c. But 1 by a is coming inverse out. Something we made wrong. 1 by k they have an intercept. How 1 by a the intercept? I think they have taken log value, right? Hmm? It is a log value only. Then you will get the value, isn't it? This is slope only. You have to take the log value. Then you will get the 1 by a. correct? That will be log 1 by a. Hmm? You have to apply here log, isn't it? Apply log, then you'll get the answer. Second order. Have you understood this one? Yes.
Yes, sir.
This is 1 by log. If you put the log, then you will get the answer. Then for third order, now we have to use the third order reaction. So you will get the graph 1 by a minus x whole square. This is time t. And you will get the same graph. Hmm? So this slope is your, this intercept is 1 by a square. Okay, that's the one. Here again formula is same only. So kt now 2kt is equal to, we can apply 1 by a minus x whole square and divided by 1 by a square. So this is the graph. I think here for second order we have the graph is kt is equal to 1 by a minus x. I think this is the, you can write here also, kt is equal to 1 by a minus x minus 1 by a. This will be better. Then you can able to understand. Hmm? So we can say clearly here. So this is your 1 by a minus x is your whole square equal to 2kt plus 1 by a square. So we can say clearly this is y equal to m into x plus c. I think now clear, isn't it? Yes or no? Hmm? Yes. Can you able to understand? Isn't it here? Tan theta will be 2k. Yes. Have you got? Are you getting or not?
Yes, sir.
Huh? I think if you practice carefully, actually I have given all notes. So if you practice carefully, I think you won't have any problem, right? Hmm? So you can write yourself 0, first, second, third order, no problem. Yes. So this also plot over first order, second, and third order. I think all plot over. We have to go for next is the Oswald dilution graphical, okay, half-life method. Third is the half-life method. In half-life method, you already know T1 by is proportional to a to the power n minus 1, or we can write here a to the power 1 minus n. So we have two values there. And what is the n? N is the nth order of a reaction. So already we have seen this also for the half-life also, isn't it? Half-life we have plotted the graph, na half-life. Half-life we have plotted the graph. No. Half-life we plotted now. A, B, C. This is half-life we plotted the graph. You leave it. Half-life plotted now. Huh? We can use fractional change method. Fractional change method. In that case, T1 by n is proportional to A1 by n. Okay. So let the time required to complete a definite fraction to time required to complete a definite fraction, okay, that are T1 and T2 when initial concentrations are initial initial concentrations are T1 and A2 respectively. Then so we can see T1 is proportional to A to the power 1 minus n, and T2 is proportional to A to the power, this is the A1, this is the A2, 1 minus n. So T1 by T2 is equal to A1 by A2 to the power 1 minus n. Or we can write here A2 by A1 is equal to n minus 1. Hmm. Applying log, like applying log A to A2. Oh, A1, A1, sorry. It will be A1. Hmm. Because for T1, A1 concentration, for T2, A2 concentration. Okay. So this is the half-life definite fraction only, applying log on both sides. So you will get here log T1 by T2 is equal to, this is the n minus 1, log A2 by A1. So what is the n value? So hence n is equal to n is equal to 1 plus 1 plus log T2 T1 minus log T2 divided by log A2 minus log A1. This is for definite fraction. We can take fraction 2 by 3, 3 by 4, like that. Okay. If you use the half-life, you will get the in terms of half-life only, isn't it? Yes. Some actually mostly they will ask you the equation, which of the following equations correct, right? So in that case, this will be very helpful. Otherwise, all these are for the higher level only. Then we have Ventoff differential method also. This you can derive yourself. Yes, I'm not driving all this thing. Yes, can you drive all this yourself? Huh? Yeah. Next is our E, that is the Ventoff differential method. Ventoff differential method. Yes, somebody wrote here. Oh. In Ventoff differential method, in this method, the rate of reaction is observed rate of reaction is observed at different initial concentration at different initial concentration of reactants. Okay, let the rate of reaction is R1 and R2 is R1 and R2 at initial concentration C1 and at initial concentration C1 and C2 respectively. C2 respectively. So R1 is equal to K. K will be constant. Okay. So this will be your C1 to the power n. Okay, because nth order, and same we can take R2 will be equal to K is constant. No, R2 to K will be constant, and it will be C2 raised to the power n. Isn't it? So this R is nothing but the, we can say dC1 by dt. This R2 will be your dC2 by dt. Okay, this is the rate only now. So if you dividing the equation 1, these two equation, we can mark it. So dividing equation 1 by equation 2. So we get R1 by R2 is equal to C1 by C2 to the power n. Okay. And if you have to multiply by log, then applying log on both sides. Then apply log on both sides. Then we'll get what we'll get here. So log R1 by R2 equal to n into log Cn by C2. Then what is the value of order? So here order will be, so order means this is the order now. And this is the order only. So order will be equal to log of R1 by log of R2 divided by log of C1 minus log of C2. Got it? So in fractional change method, we found the order. Okay. And in Venn of differential method, we found the order. Right? Got it? Clear? Yes. Hmm? Yes, okay. And uh, we have also initial rate method also. So initial method already we have discussed also, right? So we have different type of concentrations given, and with the help of initial rate method, we can also find the this one, your uh, order of the reaction. Okay, based on the experiment. If you remember, like suppose when hypothetical reasons m into a plus m into b plus m3 is giving you product. Okay, and for initial rate is equal to k into a to the power alpha, b to the power beta, and c to the power of gamma. Okay, so we can also write here. So if you see first set of initial reaction, initial rate, first set, we can put R1, K, and we can put here A1 to the power alpha, B1 to the power beta, and C1 to the power gamma. Then second set we can also take uh, second set of initial rate, second set. So we can take R2. So K, this becomes your A2. Okay, and we can take here same alpha. This will be B2 will be beta, and C2 will be your gamma. So we got the two equations here also. This is the equation 1, equation 2, and equation 3. So you have to divide by 3 by 2 by 3. So dividing 2 by 3. Okay, so we get here R1 by R2 is equal to, so we can take, so if you divide by 3, so you have to take the divide by 2 and keeping B and C constant. Okay, we have to take constant now. If you take B and C constant, then R1 R2 will be equal to A1 by A2 into alpha, right? Hmm? Then if you take the log value, now you can take the log value in both sides, taking log on both sides. So we'll get here, so log of R1 by R2 equal to alpha into log of A1 by A2. So here again, alpha is equal to log R1 minus log R2 and divide by log of A1 by A2, right? A1 minus log of A2. Understood now? Yes. Yes, clear. So we can find the alpha, similarly we can find the beta, similarly we can find the gamma. Then alpha plus beta plus gamma will give you the order of the reaction. Yes, clear? Yes or no? Yes. Okay, so shall we continue tomorrow? Yes?
Yes, sir.
Not tomorrow, I think Friday, right? So Friday we'll completely we'll get some problem, and then we'll continue the next topic, that is called your theory of reaction rates. Okay, we are going to be end of this session. Okay, 4-5 class required. Chemical kinds will finish. Okay, shall I end meeting? I'm ending meeting. Okay, bye then. See you on Friday. Yeah.